Tapestry is a web framework developed by Howard Lewis Shipp. Before becoming an Apache project, Tapestry was integrated into the Jakarta project. One of the main features of the Tapestry framework is in simplicity. Indeed, all the Tapestry classes are simple Java classes, called POJO, plain old Java objects. Tapestry also offers a lot of tools, facilitating the development phase. For example, a very detailed error reports, or the hot reloading with Jetty, which allows us to visualize changes without restart the server. The latest stable version of the framework, 5.2.4, uses the basic concept of the JDK 1.5, like the annotations or the generic types. The framework also offers us a bridge to use other technologies, like Hibernate or Spring. Everything is here to make your development easier and more efficient. You will create dynamic web application. You will be able to make your template file interacting with your Java model. It will be a robust application because Tapestry is not a toolbox or an action-oriented framework. It is a component-oriented framework. It has many years of development behind him. It is very robust. With all these versions, we can say that Tapestry is currently responding to all issues related to a web application, like the resource or session management. You will create a scalable application because Tapestry makes maximum use of the HTTP session. You can run your application on a lot of servers, like Jetty or Tomcat. Tapestry is based on the standards of the Servlet API. However, the manipulation of these standards is transparent for the developer. Tapestry is based on interface in POJO. It is unnecessary to extend specific classes. This feature allows you to be independent of the Tapestry technology. Tapestry is also based on the IOC mechanism operated by Tapestry. You can use annotation with Tapestry. If you want to store something in the HTTP session, you simply add the @persist annotation at the top of the variable, and Tapestry will make everything for you. Tapestry is designed to be a component-oriented framework. Your application will consist of a set of pages and components, and each component can be made with other components. It's totally different from Spring MVC and Struts. Tapestry will manage a lot of things for you, the request processing and the creation of the URLs, for example. Managing the user session is transparent to the developers. They do not need to use directly the HTTP session. Tapestry provides a detailed error report which facilitates the development and debugging of your application. Developing with Tapestry is writing a template and associate it to a Java class. The Java class will be an object that will define your page. The template will contain the markup. This is the presentation of your page. Tapestry is made up of 5 modules. Tapestry IOC is the base of the Tapestry project. Tapestry Core is a framework for developing a web application. Tapestry Annotation is useful if you want to use annotation in your Java class. Tapestry Upload provides an upload component. And finally, Tapestry Test will be used for your unit test. Some others exist in order to integrate Spring or Hibernate. What is Tapestry, technically speaking? It is a G2E filter. We will have to declare this filter in your web XML file and create the mapping. A component is made up of a Java class and an HTML template. The Java is a plain old Java object. You will use annotation to describe how the component has to be. Your template file is a valid XML document. We cannot use not well-formed HTML template because it will not be parsed and Tapestry will throw an error. What is the difference between a page and a component? Just 2 differences. You will put the component into the components package and your pages in the pages package. And a component do not have an activation phase. We will see what is an activation later. We have 2 types of requests, action request and render request. And every time we have an action request, we will automatically have a redirect just after to a render request. For example, when you will click to delete this row in a grid, for example, it will delete the row and refresh the page. We will have 2 requests. This request avoids certain issues with some users' action, for example, refresh the form several times. The action request will generate an event on a specific component. The return value of this event will define what will be returned to the user. For example, after submitting a login form, it is an action request, the user will be redirected to the main page of your application. It is a rendering request. A rendering request will return the generated HTML for a given page. In Tapestry, you have a pool of objects. Tapestry will have in its pool a number of pages and components instances. When a user will visit a page of your application, Tapestry will take an instance to the pool and will send it to the user. And when he will finish with this page, Tapestry will put the page back to the pool. You can execute some specific actions during these various steps of the component's life cycle. We just have to annotate the method we want to execute with the right annotation. So we have the add page loaded when an instance of a page is created, and we have add page attached when a page is associated to the thread of the user, and add page detached when the page is returned to the pool. So what's happening? The first time I access to a page, Tapestry will check if the page exists. That means if the page has already been instantiated. If it does not exist, it will create one instance of your page, instantiate the components associated to your page, and aggregate all these elements. Finally, Tapestry will inform the developer that an instance has been created with the page loaded event. Once the page has been loaded, it will attach this instance to the current thread. This is the page attached event. The page is executed. At the end of the request processing, the page is detached. The Java instance is cleaned. You can add extra cleaning if you want, and Tapestry will put back this instance to the pool. The second time I access to the page, Tapestry will check if the page is available in the pool. It will skip the page loaded because the instance already exists. It will put the existing instance of the page to my thread, execute the request, and then detach it. The number of instances available in the pool is configurable in your IOC module class. We will see it later. The objective of Tapestry is convention over configuration. Tapestry do not use XML. Everything is made to not use XML, just Java and annotations. The second objective of Tapestry is don't repeat yourself. Your Tapestry application will be almost configured in your Java class. Only one thing has to be configured in XML. It is your servlet deployment descriptor, web.xml file. This configuration will be nearly the same for all applications. First, you have to define the root package of your application. For that, you will use the Tapestry app package context parameter. Tapestry will use it to locate all your pages and components classes. In this example, all your Java class will be in the NetAtos formation Tapestry package. Secondly, we have to define the name of your application. This name will be the same as the Tapestry filter name. This name is very important. It will be used for your application module class. We will see it later. Here is a basic structure of a Maven project. We'll find the SRC main Java for your Java class, and the SRC main resources for your template and for your properties file. By convention, we also put all the static resources, CSS, JavaScript, pictures, in the static directory of the web app in your application. This is the package structure of a Tapestry 5 application. You will have to respect these structure rules to design your applications. You will have pages. This package will contain all your page, components for the components of your application, services for all your services. It will contain the configuration module of your application. Mixin is the particular type of component. It is used to add some behavior to an existing component. For example, if you want to add an autocomplete behavior to one of your text fields, you will use a mixin. The base package will be used to create abstract component that you will not use directly. The package data this package is a OAT recommendation, but it's not mandatory. Most of the configuration have to be defined in your applications module class. This class will define new services, override some configuration, for example, thanks to a set of predefined methods. Tapestry will look for this module in the services package of your application. The name of this module has to start with the name of the Tapestry filter defined in the web.xml file and appends with module. If we call our Tapestry filter Tapestry app, our application module will be Tapestry app module.java. It is not mandatory to have a module in a Tapestry application. If it exists, Tapestry will add it to the IOC registry. A part of your application will be configured via symbols. The symbols can be overridden by using the contribute application defaults method in your app module class. These parameters can also be overridden in your web.xml or with an option in your JVM command line. Here are some very interesting symbol constants. The Tapestry start page name is the name of the page that will be rendered for the root URL. Tapestry supported locals, the comma-separated list of supported locals. Tapestry compress white space, suppress all the white space in the generated HTML page. Tapestry production mode, a flag indicating whether the application is running in production or in development. In development mode, we will have access to some interesting functionality, for example, a complete error report page, for example.